Welcome back to our YouTube channel. If you haven't subscribed, kindly click on the subscribe button. Today, I will be taking you through how to provide lasting solution to resolution of vector. What do I mean? Lasting solution to resolution of vector. Contrary to your belief that wherever you are resoluting vector, your horizontal axis must be taking cos while your y-axis will be taking sine. No, that your orientation is wrong. The axis that will take sine or cos depends on the location of your angle. Let's look at this together. Let's look at this question together. This is our y-axis and this is our horizontal axis. Let us assume at the horizontal axis here we have a force of 20 Newton, and for the vertical axis we have a force of 10 Newton. Now we're having a force acting at an angle to the vertical, and the force is of 5 Newton. Let's assume that the angle between the vertical axis and the line of action of this force, that is the 5 Newton force, is 30 degree. Now, the question is, how are we going to find the resultant of these three vectors? I think you know that when two vectors are acting in the same direction, for example, we have F1, F2. Don't forget, force is an example of a vector quantity. So if the two of them are acting in the same direction, the resultant or net force is simple. It is summation of these two forces because the two of them are acting in the same direction. That is, our R will be equal to F1 plus F2. If the two of them are acting in opposite direction, that is, we have two forces acting in opposite direction. We have F1 acting at point O. We also have F2 acting at this same point but in opposite direction. Our resultant vector is equal to F1 minus F2. Now, in a situation whereby the two forces are acting perpendicular to each other, the two of them are acting perpendicular to each other. That is, we have F1 and what? And F2. Our resultant will be the third vector which is acting our resultant will be the third vector. This is the third vector R, which is acting from the common point of these two other forces. That is, the force that will have the same effect as these two other forces combined together, and this is our R here. To get this R, this our F1, we produce, since it is vertical force, we produce it here. We are using dotted line to indicate that it is this force we are referring to and this is not its original position. So we have the force F1 here. So this is our F1, this is our F2, meaning that using Pythagoras theorem, we will be able to get our R, which implies that R square is equal to F1 square plus F2 square. In that case, our R is equal to square root of F1 square plus F2 square. But the question we have at hand here is different. The two forces here in the same direction, in this case opposite direction, in this case perpendicular to each other. Now we are having three forces. The first one vertical, the second one horizontal. Now we are having another force acting at an angle to vertical. How are we going to do that? The first step is to resolve this 5 Newton force to both horizontal and to the vertical. We resolve to both horizontal and the vertical. Now we are having the angle to the vertical. Listen very well. your own belief, your belief is wherever you are resulting a force to the horizontal, it will be that force cause the angle you have. Wherever you are resolving to the vertical, you think that it will be that force cause the angle you have. No, it depends on the location of the angle. If you have that angle between the line of action of the force and the axis that you are resolving to, meaning that it will be cos. And if you are resolving to an axis in which the axis doesn't possess the angle, meaning that it will be sine. So in this case now, if we are to resolve the 5 Newton force, meaning that it will be to the vertical, we are having 10 Newton force here already, then plus this 5 Newton that we are about to resolve. So when we resolve to the vertical, since the angle is in between the line of action of this force and the vertical, then it will be 5 cos 30. 5 cos 30. This angle is between the line of action of this force and the vertical. Now let's resolve to horizontal. To the horizontal, we have 20 Newton force in position. We write that 20 plus this 5 Newton that we are about to resolve. So when we resolve this 5 Newton, look at the angle. It's between the line of action of force and the vertical, not to the horizontal, meaning that resolving to the horizontal will be what? Will be sine. So this one will be, sorry, it will be 5 sine 30. Now we are having the two forces acting at right angle, that is acting perpendicular to each other. So our resultant will be the third vector, which will have the same effect as these two other forces acting together. So meaning that we are going to have our R here. So the vertical force we are going to have it here. So that vertical force, the vertical force is what we have here. This vertical force is the same thing as this, that is 10 plus 5 cos 30, and this is our horizontal force, which is what? 20 plus 5 sine 30. So if that is the case, what will be our R, which is the resultant? R will be equal to square root of 10 plus 5 cos 30 everything square plus 20 plus 5 sine 30 everything square. So now we have R to be equal to, everything is now mathematics. 10 plus 5, what is cos 30? Cos 30 is equal to 0.866 plus 20 plus 5. What is sine 30? 0.5 everything square. So we have R to be equal to square root of 10 plus 5 times 0.866 is equal to 4.33. You have it square plus 20 plus 5 times 0.5 2.5, as simple as that, everything square. So we have our R to be equal to, so our R is equal to square root of, don't mind my biro, square root of 14.33 square plus 22.5 everything square. So our R is equal to square root of 205.3489 plus 22.5 square. 22.5 square, 506.25. So our R will be equal to square root of square root of square root of 506.25 plus 205.3489. That is square root of 711.5989. What is that? Square root of square root of 711.5989 is equal to, our R is equal to 26.6758. So meaning our final answer in two decimal places is equal to 26.68. So the resultant is also false, meaning that it will be measured in Newton. Here is the final answer. Yeah. Thanks for watching the video. If you haven't subscribed, kindly click on the subscribe button. I think you find it interesting. You can see it is one-on-one physics class, unlike your class, which is somehow cumbersome. Maybe you are 100 or plus in class, so you will find it interesting. Click on my next video for better understanding on this or any other topic.